How to play football. Football needs special equipment. A college covered with ivy, a coliseum or stadium filled to overflowing with 100,000 rabid, wildly cheering fans, great armies of vendors, managers, mascots, photographers, sports writers, doctors, elaborate brass bands, assorted coaches, old grads, scores of Annie Oakleys, and two teams resplendent in brilliant uniforms create a riot of color and atmosphere unequaled by any other game on earth. Now, the object of the game is to advance the ball over the goal line to the opposing team by hook or crook. 11 men on either team, two ends, and that's how the game is played. Now the teams line up for the kickoff. The referee blows his whistle, and the game is on. It's a long, high end-over-end kick over the end zone into the arms of Swivel Hip Smith, that great All-American star, triple threat scat back. Look at him go. They can't touch him. He can really carry the mail, that boy. Look at that open field run. Look at that straight arm. He's away, and he's over for a touchdown. Well, it isn't often you see this happen. 105 yards to a touchdown on the opening kickoff.
Hi everyone! Physics is the branch of science that deals with the physical world. The branch of physics that is most relevant to football is mechanics, the study of motion and its causes. We will look at three, not one, not two, but three broad categories of motion as they apply to the game. Delivery of the football through the air, woo! Runners on the fields, and stopping the runners on the field. Watching a weekend football game could teach you something other than who threw the most passes or gained the most yards. Football provides some great examples of the basic concepts of physics. It's present in the flight of the ball, the motion of the players, and the force of the tackles. Watching a weekend football game could teach you something other than who threw the most passes or gained the most yards. Football provides some great examples of the basic concepts of physics. It's present in the flight of the ball, the motion of the players, and the force of the tackles.
Weber rolling out. And he's going to throw deep for Decker. What a grab! Touchdown, Minnesota! Decker shaken up as he got hammered after a beautiful catch.
It looks like that hit on Golden Gopher wide receiver Eric Decker didn't feel too good. The blast from Cal safety Sean Cattouse had enough force to cut Decker's jaw open, and while Decker clearly was uncomfortable after the hit, the Gopher athletic staff was able to stitch him up so he could get back in the game, which is pretty amazing considering the force his body withstood. But hold on a minute. Just how much force did Decker endure? How hard was that hit? Knowing the time and the distance at which he landed, we can now calculate what the velocity was. This is an example of how football relates to physics, and how physics is a part of our everyday athletic lives.
Where was the ball when he got hit? Did the ball cross the plane?
It looked like the ball was crossed, and that was a good adjustment by both Weber.
When a quarterback launches a ball into the air, it follows a path. As the ball climbs skyward, there is a force acting on it, gravity, which slows it down as it reaches its peak height. It stops for a very brief instant, and then the ball begins to come down. Gravity is pushing it as it accelerates downward. You're probably wondering why a football has laces. The laces allow the quarterback to get a grip, so they can spin the ball as they release it. The spin is the key. Most oblong objects become unstable and tumble end over end when thrown. But with a football, the spin, which gives it the spiral, gives us a motion like that of a gyroscope, which keeps it pointed in the same direction, with the pointed end leading the way. Now, how do you get that tight spiral? The harder the ball is thrown, the more torque of the fly that leaves the hand, so it spins faster, leaving it more stabilized so you can have a tighter spiral. Did you know that tighter spiral spinning about 400 to 600 RPMs cuts through the air, reducing drag from the air, and actually achieves the same lift that keeps airplanes in the air. Blocking and tackling. Tackling and blocking runners relies on three important principles of physics. 1. Impulse. 2. Conservation of momentum. And 3. Rotational motion. When a runner and tackler meet, when a running back is moving in the open field, he has a momentum of 960 kilograms per meters per second. To stop him, you need to change his momentum. A tackler must apply an impulse in the opposite direction. Impulse. This is the product of the applied force and the time over which that force is applied. Repeat. Impulse is the product of the applied force and the time over which that force is applied. Because impulse is a product, like momentum, the same impulse can be applied if one varies either the force of impact or the time of contact. If a defensive back wanted to tackle our running back, he would have to apply an impulse of 960 kilograms per meters per second. If the tackle occurred in 0.5 seconds, the force applied would be the tackling process. Coaches often tell their players to tackle a runner low. In this way, the runner's feet will be rotated in the air in the direction of the tackle.
There's a penalty on the play. It's against Taxidermy.